Welcome to Still Science Lab. Tonight, we explore about quantum foam, where space and time stop existing. We live our entire lives suspended within a deeply comforting, mathematically necessary illusion. When we step outside in the freezing dark and look up at the sprawling expanse of the night sky, or when we simply stare across the quiet, mundane distance of an empty room, we perceive space as a perfectly smooth and continuous void. We inherently, instinctively believe that nothingness is just a passive, empty container. We view the universe as a silent, unmoving stage, an infinite black theater waiting patiently to be filled with the brilliant light of stars and the heavy mass of planets. But this intuitive, everyday perception is a profound deception. The central mystery we are about to unravel is that true, absolute emptiness does not exist anywhere in the cosmos. The smooth, silent void is a macroscopic lie, masking a microscopic arena so relentlessly violent and chaotic that the very concepts of distance, geometry, and time are completely obliterated. To understand why we are so easily deceived by the vacuum, we must first confront the severe limitations of our own biology. We are giant, slow, heavily macroscopic creatures. Our brains and our fragile sensory organs were forged by evolution on the surface of a terrestrial, sunlit world, specifically tuned to help us survive in a landscape of solid, interacting objects. We evolved to calculate the parabolic trajectory of a falling rock, to judge the physical distance between a predator and ourselves, and to navigate a reality defined entirely by tangible friction, heavy mass, and mechanical boundaries. Because of this evolutionary heritage, our minds are rigidly programmed to treat space as nothing more than the physical, empty distance between two solid points. Space, to the human mind, is merely the room in which reality is allowed to happen. It is the blank canvas hiding behind the painting. We do not feel space. We do not hear it. It offers absolutely no physical resistance to our moving hands. Therefore, we naturally assume it possesses no properties of its own. We assume it is simply nothing. This perception of an empty, passive container brings our species a deep psychological comfort. It provides an absolute, unchanging backdrop to the chaotic, unpredictable events of our daily lives, even as the macroscopic world around us shifts and decays. As the seasons ruthlessly turn, as ancient mountain ranges slowly weather away into dust, and as living things grow old and inevitably die, we take silent solace in the idea that the underlying framework of the universe is permanently, fundamentally stable. The void, we assume, is eternally quiet. For centuries, the greatest minds in human history shared this exact biological intuition. The architecture of classical physics was built entirely upon the idea of an absolute, unmoving framework. Isaac Newton viewed space as a rigid, invisible grid, an infinite and passive stage where the mechanical clockwork of the cosmos ticked away with perfect, predictable precision. Then came Albert Einstein, a mind that fundamentally shattered the rigid grid of the Newtonian universe. With the publication of General Relativity, Einstein completely rewrote the rules of reality, proving that space and time are not separate, independent entities, nor are they a passive backdrop. He revealed that they are fused together into a single, dynamic, four-dimensional continuum known as spacetime. The stage itself became an active participant in the cosmic play. Matter tells spacetime how to curve, and curved spacetime tells matter how to move. The void was no longer an empty, rigid box. It was a flexible, physical medium. In the elegant, sweeping mathematics of general relativity, this fabric of the universe is often conceptualized much like a taut, stretched sheet of rubber. It is a deeply beautiful, almost poetic vision of the cosmos. When a massive object like a star or a black hole is placed upon this fabric, the geometry of space-time warps and sags under the immense weight, creating the invisible valleys and steep gravitational wells that dictate the orbital dance of the planets. When two supermassive black holes collide in the distant dark, they send violent ripples of gravitational energy propagating outward across the void, stretching and squeezing the continuum like waves traveling across the surface of a silent pond. But while general relativity gave the void a dynamic, bending geometry, it also heavily reinforced our deepest biological illusion. In Einstein's equations, the fabric of space-time remains beautifully, flawlessly smooth. It is a continuous geometric curve. According to the strict rules of this classical model, you could take a theoretical magnifying glass to the fabric of reality and zoom in infinitely, dividing space into smaller and smaller increments forever, and it would always remain a perfectly flat, uninterrupted surface. There are no sudden tears. There are no jagged edges. The macroscopic universe, governed by gravity, is a realm of sweeping, continuous curves. It is a reliable, predictable canvas that holds the staggering mass of galaxies in a delicate, elegant balance. For decades, this smooth, geometric vision of the cosmos stood as the ultimate triumph of human intellect. We had mapped the stage, and we understood its curves. But theoretical physics is a discipline of relentless, unforgiving inquiry. We could not stop at the macroscopic world. We began to push our mathematics and our instruments into the microscopic abyss, peering past the heavy certainty of biology, past the intricate chemical bonds of molecules, and down into the freezing, chaotic realm of subatomic particles. And as our gaze pierced the absolute basement of existence, a dark, existential dread began to emerge from the equations. We realized, with a creeping sense of horror, that the beautiful smoothness of Einstein's universe is a grand illusion. The apparent peace of the void is merely a trick played on us by our immense scale. We are victims of our own massive size. This is not an unfamiliar phenomenon. Nature uses vast distances to hide chaos all the time. If you fly 30,000 feet above the open ocean, looking down from the pressurized, quiet cabin of an aircraft, the water below appears as a perfectly flat, smooth pane of blue glass. It looks completely motionless, a continuous surface of absolute calm. But if you were to instantly teleport down to the surface of that exact same ocean, the illusion of peace would violently shatter. You would find yourself drowning in a chaotic, roaring nightmare of towering waves, crashing white water, and deafening, turbulent energy. The smoothness was a lie generated entirely by the extreme distance of the observer. The exact same principle applies to the very fabric of reality. We look across the room, or across the vast, empty gulf between the stars, and we see the smooth pane of glass. We perceive a quiet, unbroken continuum because we are simply too large and entirely too blind to see the churning horror beneath the surface. To truly grasp the terrifying nature of the void, we must perform a radical thought experiment. We must construct a scenario of absolute, uncompromising emptiness. Imagine isolating a specific, microscopic region of deep space. We will build an impenetrable, theoretical vault around this space to isolate it completely from the rest of the cosmos. Now, we begin the process of profound removal. First, we sweep away all the heavy matter. We remove the drifting interstellar dust, the wandering rogue planets, and the cold, dead husks of ancient stars. Then, we go deeper. We scrub the vault of every single microscopic atom of hydrogen gas, ensuring that not a single piece of physical mass remains. But we are not finished. The void is still flooded with energy. So, we extract every single photon of light, plunging the theoretical vault into an absolute, impenetrable darkness. Finally, we drain away the ambient thermal radiation, dropping the temperature of the vault down to absolute zero, the ultimate limit of cold, where all atomic motion completely ceases. According to classical physics, and according to the heavy, intuitive logic of the human brain, we have now achieved the ultimate state of nothingness. We have created a perfect, pristine vacuum. The vault is completely empty. There is no matter to bend the geometry of space. There is no light to cross the dark. There is no heat to create vibration. What remains inside the vault should be the absolute definition of peace. It should be a silent, unmoving, and perfectly smooth stage, frozen in an eternity of quiet stillness. In the macroscopic world, if you empty a glass of water, you are left with an empty glass. The container remains, passive and unchanged, ready to hold something new. The human mind demands that space behaves the exact same way. We desperately want space to just be the glass. We want it to be a reliable, permanent infrastructure that allows the universe to function without interfering. We cling to the idea that if we remove the actors from the stage simply goes dark and waits. But the universe does not care about classical logic, and it does not obey our comforting intuitions. When we apply the unforgiving mathematics of quantum mechanics to this perfect, isolated vacuum, the illusion of peace violently disintegrates. When you strip away all the matter, all the light, and all the heat, the space that remains is not empty, it is not quiet, and it is certainly not smooth. Quantum mechanics tells us that the glass itself is an illusion. The fabric of reality is not a passive container holding the universe. It is a fundamental, hyperactive participant in the chaos. The nothingness has its own inherent properties, its own aggressive, bubbling energy, and its own relentless refusal to remain quiet. The deeper we look, the more we realize that pure emptiness is a physical impossibility. The concept of zero does not actually exist in the natural world. This revelation strikes at the very core of our existential security. If the empty space around us is not a passive container, then our entire relationship with physical reality is built on a fundamental misunderstanding. We navigate our lives believing that we are walking through space, as if space is just a harmless, yielding medium that accommodates our physical presence. When you reach your hand out into the dark, you feel no resistance. You assume your hand is moving through a void, but if that void is actually a boiling arena, then every step you take, every breath you draw, and every macroscopic movement you make is plowing through a hidden, turbulent ocean of incomprehensible violence. We are blissfully unaware that we are submerged in a chaotic storm. Einstein's vision of the universe gave us a profound sense of mathematical control. The equations of general relativity are heavily deterministic. If you know the exact mass of a star, you can predict exactly how space-time will curve around it. You can calculate the precise trajectory of a comet centuries before it arrives in the inner solar system. This deterministic smoothness provided a philosophical safety net. It suggested that at its most fundamental level, the universe was rational, orderly, and beautifully geometric. It implied that if we just had sharp enough mathematical tools, we could map every curve and every valley of reality with absolute precision. But the discovery that this smoothness breaks down is not just a mathematical curiosity. It is the death of that deterministic dream. It means that there is a hard, terrifying limit to the order of the cosmos. This forces us to reevaluate everything we consider solid and real. The heavy matter that makes up your body, the carbon in your cells, the calcium in your bones, the iron in your blood, is overwhelmingly composed of empty space. If you were to scale up a single hydrogen atom so that its nucleus was the size of a marble sitting in the center of a massive stadium, the electron would be a tiny speck flying around the highest bleachers. Everything in between is that exact same empty space. We are, quite literally, made of the void. And if the void is not a quiet, empty continuum, but rather a seething, violent frenzy of microscopic activity, then the very foundation of our physical bodies is built upon an architecture of pure chaos. The stability we feel in our flesh is just as illusory as the stillness we see in the night sky. To fully internalize this existential dread, you must look at the empty space immediately surrounding you right now. Look at the seemingly peaceful, quiet gap between your own two hands. It feels entirely devoid of consequence. It is utterly silent. But that silence is a biological lie, a necessary sensory filter designed by evolution to keep your conscious mind from shattering under the weight of true reality. If your eyes were suddenly tuned to the ultimate microscopic scale, if the protective illusion of the macroscopic world were violently ripped away, you would not see a quiet, empty room. You would witness an apocalyptic storm of geometric distortions and fundamental energies tearing themselves apart. You would see the very foundation of existence trembling on the edge of complete mathematical collapse. The passive void you have trusted your entire life would be exposed as a volatile, roaring abyss. When you reach the absolute bottom of reality, where the laws of macroscopic physics completely break down, the dark is not dead. The nothingness is boiling. To understand the true, terrifying nature of the void, we must first completely abandon the comforting dimensions of the human experience. We are creatures imprisoned in the middle scale of the universe. We measure our lives in inches, miles, hours, and years. We interact with the world through a heavily filtered biological lens, interacting only with massive, highly organized structures composed of trillions of atoms. This middle scale is a realm of solid geometry, predictable gravity, and reassuring stability. But this stability is a localized illusion, a fragile piece that only exists because we are suspended perfectly between the crushing immensity of the cosmos and the boiling chaos of the microscopic abyss. To see the universe as it truly is, we must step off this safe, macroscopic island. We must undertake a journey of profound descent, shrinking our perspective down through the layers of physical reality, past the familiar, past the strange, and ultimately, past the very limits of physics itself. Imagine leaving the macroscopic world behind. We push past the boundary of human skin, descending into the dense, wet, and violently active machinery of a living biological cell. Here, proteins fold and unfold in a frantic, microscopic dance, driven by the relentless chaos of thermal energy. We dive deeper, pushing past the twisting, sacred architecture of the DNA double helix. We are now entering the realm of chemistry, where complex molecules assemble and break apart, bound together by the sharing of electrons. But we cannot stop here. Chemistry is still too structured. It is still too close to the human experience. We plunge further, penetrating the outer shell of a single carbon atom. As we cross this threshold, the dense, chaotic world of biology instantly vanishes, replaced by a staggering, overwhelming emptiness. The atom, the fundamental building block of everything you have ever touched, is almost entirely a void. If you were to expand the nucleus of an atom to the size of a marble and place it on the 50-yard line of a massive football stadium, the electrons would be tiny, jittering phantoms orbiting high up in the farthest bleachers. Everything in between is a freezing, silent dark. We drift through this vast, subatomic canyon, leaving the ghostly electron clouds behind, and approach the terrifying density of the nucleus. The nucleus is a tightly bound fortress of protons and neutrons, held together by the strong nuclear force, an interaction so staggeringly powerful that it easily overpowers the violent electromagnetic repulsion trying to tear the particles apart. We breach the fortress. We dive into the proton itself, and here, the very concept of solid matter permanently dissolves. We have reached the domain of the quarks, the fundamental, indivisible constituents of matter. They are bound together by an ocean of virtual particles, a boiling, frantic exchange of energy that happens at blinding speeds. We are now firmly inside the quantum realm. This is a landscape governed by probability, uncertainty, and paradox, where particles can exist in multiple states at once and teleport through impenetrable barriers. For most of modern science, the quark was considered the absolute end of the line. It was the fundamental pixel of reality, the smallest possible increment of physical matter. But matter is not the stage. It is merely an actor upon the stage. To find the absolute bottom of reality, we must look at the stage itself. We must leave the quark behind and descend into the pure, unadulterated emptiness of the spatial vacuum. We are now shrinking down into the quiet dark between the particles, and as we continue to shrink, we realize that the distance between the human scale and the quantum realm of the quark is nothing compared to the terrifying, bottomless gulf we are now entering. The quark is unimaginably small, yet compared to the true basement of the universe, a quark is a sprawling, colossal mountain range. We are diving into a scale of distance so profoundly alien that the human mind physically lacks the architectural capacity to properly visualize it. We are approaching the Planck length. In the language of mathematics, it is roughly 10 to the power of -35 meters, a decimal point, followed by 34 zeros, and then a 1. To even attempt to grasp the crushing magnitude of this number requires us to stretch an analogy to the absolute breaking point. Imagine taking a single, fragile atom of hydrogen and artificially inflating it until it is the exact size of the entire observable universe. Let that sink in. The atom is now 93 billion light-years across, containing hundreds of billions of galaxies within its expanded borders. If you were to look at that universe-sized atom, the Planck length would be roughly the size of an average, macroscopic tree standing on the Earth. That is the staggering, incomprehensible depth of the abyss we have descended into. But the Planck length is not just a measurement of something incredibly small. It is not merely another tick mark on a cosmic ruler that stretches downward into infinity. The Planck length is a hard, mathematical boundary. It is the absolute, uncompromising threshold of physical reality. In our macroscopic world, we naturally assume that you can always cut a distance in half. If you have a millimeter, you can divide it into a half millimeter, a quarter millimeter, and so on, forever. We assume that space is an infinitely divisible continuum, but the universe imposes a strict, terrifying limit on this infinite reduction. Below the scale of 10 to the power of -35 meters, the very concept of distance completely loses its physical meaning. You cannot have a half of a Planck length. The universe simply will not allow it. It is the absolute smallest increment of space that can theoretically exist. It is the fundamental, indivisible pixel of the spatial geometry. And because space and time are intimately, permanently woven together into a single, dynamic continuum, this hard limit on distance also creates an absolute, unyielding limit on time. If there is a shortest possible distance in the cosmos, there must also be a shortest possible duration required to cross it. This is the Planck time. It is the amount of time it takes a photon of light, traveling at the absolute maximum speed limit of the universe, to cross one single Planck length. It is roughly 10 to the power of minus 43 seconds. This is the fundamental shutter speed of reality. It is the absolute shortest tick of the cosmic clock. Below this infinitesimal fraction of a second, the concept of before and after violently shatters. Time ceases to be a smooth, continuous river flowing steadily from the past into the future. Below the Planck time, duration itself is rendered completely obsolete, entirely dissolved into a static, meaningless haze. We have reached the ultimate, freezing floor of the universe. And it is here, at the exact, jagged edge of the Planck scale, that the greatest intellectual triumph of human history meets a violent, catastrophic end. For over a century, Albert Einstein's general relativity has served as the flawless, undisputed master of the macroscopic cosmos. It describes a universe where space-time is a beautifully smooth, continuous, and flexible geometric fabric. It is a theory of sweeping, elegant curves, where gravity is simply the natural consequence of massive objects gently bending the continuum. It is a deeply comforting, deterministic framework that allows us to predict the orbital dance of galaxies and the terrifying geometry of black holes with absolute mathematical precision. It paints a picture of a universe that makes fundamental architectural sense. But as we press our perspective down to the Planck length, this beautiful, smooth geometric fabric begins to violently warp and fracture. The elegant curves of general relativity are suddenly subjected to the brutal, chaotic, and unpredictable laws of quantum mechanics. These two monumental pillars of modern physics, one governing the massive and the smooth, the other governing the microscopic and the jittery, are fundamentally, mathematically incompatible. For decades, they have stood in total isolation, ruling their respective domains, stubbornly refusing to reconcile. And when you force them to occupy the exact same space, at the absolute basement of existence, they violently collide. At the Planck scale, the smooth rubber sheet of Einstein's universe is not just bent, it is torn, shredded, and twisted into a chaotic, boiling frenzy. The laws of physics, the comforting rules of cause and effect, the conservation of energy, and the fundamental architecture of geometry are completely obliterated in the crossfire. The mathematics that we use to describe the flight of a bird, the ignition of a star, and the expansion of the cosmos suddenly produce impossible, screaming infinities. The equations break, the theories shatter. Human understanding hits a dark, impenetrable wall. We are entering a realm where physics, as we know it, simply stops working. This is the ultimate existential terror hidden in the dark. We construct our entire worldview on the deeply ingrained belief that the laws of nature are absolute, eternal, and perfectly stable. We trust the physical world because we assume it is governed by an unbroken chain of rational mechanics stretching all the way down to the bedrock of reality. We lean on the laws of physics as if they are the ultimate, unwavering truth of the cosmos. But the descent to the Planck scale reveals a haunting, terrifying revelation. The rational, predictable laws of physics are not fundamental at all. They are merely a macroscopic illusion, an emergent property that only exists because we are looking at the universe from a safe, massive distance. When you look at your own hand, you see solid flesh. You feel the reliable, biological structure of bone. But beneath that flesh, beneath the quiet vacuum of the atom, and beneath the jittering energy of the quark, lies an absolute, mathematical apocalypse. The foundation of your body, the foundation of the earth, and the foundation of the very space that holds the stars is resting directly on top of a shredded, violent landscape where time has no direction and distance has no meaning. We are separated from this total physical collapse by nothing more than the fragile, arbitrary illusion of our own massive scale. The void is not a quiet, empty stage waiting patiently for the universe to unfold. It is an arena of incomprehensible violence, constantly threatening to tear itself apart, and we are suspended delicately, blindly, over the absolute limit of reality. There is a profound, deeply ingrained human instinct to seek out the absolute bottom of things. When we are overwhelmed by the relentless noise and the suffocating complexity of the macroscopic world, we instinctively look for a baseline. We search for silence. We crave the concept of zero. In our mathematics, zero is a comfortable, reliable, and entirely necessary anchor. It represents a clean slate, a state of perfect rest, a true and uncorrupted emptiness. For centuries, classical physics operated on this exact same comforting assumption. It was universally believed that if you took a specific region of space and meticulously emptied it, removing every single atom of drifting gas, capturing every stray photon of light, and draining away the very last, lingering whispers of ambient heat, you would finally reach this perfect baseline. You would be left with a true vacuum. You would uncover a silent, dark, and utterly tranquil stage upon which the universe was built. But the cosmos, at its most fundamental, microscopic level, operates under a set of rules that violently and categorically reject the concept of perfect rest. The universe holds a deep, structural intolerance for absolute zero. To understand the terrifying truth of what actually occupies the empty dark, we must look through the eyes of one of the most visionary, imaginative, and deeply unorthodox minds in the history of modern physics. In the 1950s, theoretical physicist John Archibald Wheeler began to unravel the comforting illusion of the quiet void. Wheeler was a titan of 20th century science, a brilliant intellectual force who famously coined the term black hole and spent his entire life wrestling with the most extreme, mind-bending paradoxes of Einstein's relativity. But Wheeler realized that to understand the true, fundamental nature of empty space, he could not just look at the smooth, sweeping geometric curves of the macroscopic universe. He had to force the elegant framework of space-time to confront the chaotic, jittering, and deeply uncertain madness of quantum mechanics. The gateway to Wheeler's terrifying realization was a fundamental, uncompromising law of the subatomic realm known as the Heisenberg uncertainty principle. In our everyday macroscopic experience, we can measure the physical world with absolute certainty. You can know exactly where a stone is resting on the ground, and you can know exactly how much energy it possesses. The stone sits still. But in the microscopic abyss, the universe enforces a strict, mathematical limit on what is knowable, and more importantly, on what is allowed to be stable. The uncertainty principle dictates that you can never simultaneously know both the precise energy of a quantum system and the precise duration of time that energy exists. The more tightly you try to pin down the timing of an event, the more wildly unpredictable and chaotic the energy of that event becomes. There is a built-in, inescapable fuzziness to the fabric of reality. The universe refuses to be pinned down. It demands a state of constant, nervous vibration. Wheeler took this principle and applied it to the ultimate question of the empty void. He asked a seemingly simple question. What happens if you apply the uncertainty principle to nothingness? If a vacuum truly had exactly zero energy, and it maintained that zero energy state constantly over a specific period of time, it would violate the most fundamental law of quantum mechanics. It would mean you knew the exact energy, which is zero. and the exact time simultaneously. It would mean you had achieved absolute certainty, and the universe simply forbids absolute certainty. Therefore, Wheeler deduced a haunting, inescapable, and paradigm-shattering truth. You cannot have zero energy. A perfect, silent vacuum is a mathematical and physical impossibility. Even in the absolute darkest, emptiest stretches of the intergalactic void, where there is no matter, no light, and no heat, the uncertainty principle demands that the underlying energy must constantly, uncontrollably fluctuate. The void cannot sit still. When you take this fluctuating energy and zoom in on the very fabric of space-time, shrinking your perspective down past the biological cells, past the dense nuclei of atoms, and past the quarks, you eventually approach the absolute limit of physical reality, the Planck scale. At this incomprehensibly microscopic depth, the fluctuations of quantum energy become so intensely violent, so overwhelmingly powerful, that they no longer just happen within space. They begin to actively warp and distort the underlying geometry of space itself. The smooth, flexible rubber sheet of Einstein's macroscopic universe completely disintegrates. The quiet, continuous stage of reality is shredded beyond all recognition. Wheeler looked into this mathematical abyss and coined a term that perfectly captured the violent, churning horror of the fundamental vacuum. He called it the quantum foam. Space-time at this level is not a smooth, empty container. It is a boiling, churning, violent ocean. Imagine standing on the shoreline and looking out at the surface of the sea on a perfectly windless day. From a distance, the water appears as a flat, pristine mirror of blue glass. It looks peaceful, unbroken, and continuous. But as you zoom in closer, taking a magnifying glass to the surface, the illusion of peace begins to shatter. You see tiny ripples, shifting currents, and the chaotic interplay of water molecules. Now, imagine plummeting directly into a Category 5 hurricane. You plunge into a roaring, chaotic nightmare of crashing waves, exploding whitecaps, and swirling, turbulent violence. This is the exact transition that occurs when you descend to the bottom of the universe. The familiar, stable dimensions of length, width, height, and time are caught in a relentless subatomic hurricane. The energy fluctuations of the vacuum are so extreme that they violently twist the fabric of reality. The topology of space bends and buckles under the strain. Microscopic peaks and valleys of geometry rise and fall in a fraction of a microsecond. The continuum tears open and sews itself back together continuously. The void is not a quiet theater waiting for a performance. It is a raging, boiling frenzy of geometric chaos, a place where the very concept of a smooth, flat surface is violently, physically forbidden. But this boiling ocean of quantum foam is not merely an abstract, mathematical concept of warping geometry. The energy fluctuating within the vacuum is so intensely concentrated that it manifests in a way that defies all macroscopic logic and human intuition. According to the foundational equations of modern physics, mass and energy are entirely interchangeable. They are not different things. They are simply two different currencies of the exact same physical reality. And because the vacuum is constantly churning with wild, unpredictable, and massive spikes of quantum energy, the void possesses the staggering ability to spontaneously mint physical matter out of absolutely nothing. These fleeting, microscopic manifestations of the abyss are known as virtual particles. They are the true, restless ghosts of the vacuum. Within the boiling chaos of the quantum foam, pairs of subatomic particles are continuously, violently ripping themselves out of the dark. They always appear in pairs. One particle of ordinary matter, and one corresponding particle of antimatter, locked together in a deadly, deeply unstable subatomic embrace. They do not travel from somewhere else. They are not assembled from smaller, pre-existing building blocks floating in the void. They are literally summoned into existence by the raw, fluctuating energy of empty space. For a fleeting, almost mathematically imperceptible fraction of a microsecond, they are entirely real. They possess actual mass. They carry an electrical charge. They briefly inhabit the universe, adding their microscopic physical presence to the architecture of reality. But the universe is a strict, unforgiving, and absolute accountant. Because these particles essentially borrowed their mass and their energy from the zero-point baseline of the vacuum, they have created a massive cosmic debt. And the uncertainty principle demands that this debt must be repaid almost instantaneously. The universe will only allow the violation of zero energy to exist for an incredibly brief window of time. The moment these twin particles are born, their opposite natures draw them violently back together. The particle of matter and the particle of antimatter aggressively collide, perfectly annihilating one another. They erupt back into a tiny, silent flash of pure quantum energy, returning their borrowed existence to the void and balancing the cosmic ledger. This is not a rare, isolated event occurring in some distant, extreme corner of the galaxy. This ghostly cycle of birth and death is happening everywhere, all the time, in every single microscopic fraction of the universe. The empty space immediately in front of your eyes, the space between the screen and your face, is entirely saturated with this subatomic violence. Trillions upon trillions of virtual particles are popping into existence and annihilating each other in a ceaseless, roaring static. The vacuum is simultaneously a sprawling, infinite nursery of creation and a catastrophic, immediate graveyard of destruction. It is a boiling frenzy of matter pulling itself out of nothingness, only to be instantly destroyed by the strict, unrelenting, and apathetic laws of quantum mechanics. To truly internalize the reality of the boiling vacuum is to experience a profound, sweeping kind of existential vertigo. We spend our lives deeply anchored to the concept of solidity. We intuitively trust the heavy, reliable ground beneath our feet. We build our homes, we construct our complex philosophies, and we forge our understanding of reality on the assumption that the physical world rests on a quiet, stable, and permanent foundation. We believe that when we sit in an empty, silent room, we are experiencing a true state of peace. We take comfort in the stillness. But the quiet of the macroscopic world is nothing more than an emergent biological illusion. It is a sensory trick, generated entirely by the sheer, overwhelming scale of our own physical bodies. We are simply too massive and entirely too slow to feel the catastrophic subatomic earthquake happening constantly beneath our skin. We are blind to the boiling ocean because we are floating too high above it. Every single atom that makes up your body, every twisting strand of your DNA, and every firing, electrical neuron in your conscious mind is suspended directly over this roaring, boiling ocean of quantum foam. The solid matter you consider to be real, the flesh and bone that dictates your existence, is vastly outnumbered by the ghosts of the vacuum. The empty space inside your own body is continuously erupting with matter and antimatter, fighting an invisible, microscopic war of creation and annihilation that you will never feel. We are floating on top of a violent, churning paradox. The universe is not a quiet, empty stage waiting patiently for the grand events of cosmic history to unfold. The stage itself is alive with chaos. It is breathing. It is vibrating with a terrifying, limitless energy that refuses to be silenced. The absolute bottom of reality is not a place of rest. It is a place of endless, violent creation and immediate, catastrophic destruction. The stillness we seek does not exist anywhere in nature. The zero we crave is a comforting mathematical fiction, a lie we tell ourselves to make the dark feel less threatening. When you strip away everything you know, everything you can see, and everything you can touch, the empty void that remains is not dead, it is boiling. There is a fundamental concept that governs absolutely everything about how we experience the universe. It is so deeply ingrained in our biology, so essential to our survival and our sanity, that we rarely ever pause to question if it is actually real. That concept is distance. From the moment we first learn to walk, we instinctively understand the physical separation between 2 points. We build our entire understanding of reality on the reassuring logic of the straight line. If you want to cross a room, if you want to sail across an ocean, or if you want to launch a mechanical probe into the freezing dark to intercept a distant planet, you rely on the absolute certainty that space is a reliable, measurable medium. You rely on the assumption that the physical gap between here and there is a fixed, permanent property of the cosmos. In the macroscopic world, distance is the ultimate ruler. It is the unyielding scaffolding of reality. Even when Albert Einstein revolutionized our understanding of the universe, proving that space is a flexible fabric that can warp and sag under the crushing weight of massive stars, the fundamental reliability of distance remained completely intact. Gravity might bend the path, but the path itself still exists. The geometry of the cosmos might curve, creating deep gravitational wells and sweeping cosmic hills, but the fabric of reality is always contiguous. It is unbroken. You can always measure the shortest distance between 2 points, even if that distance follows a curve. We trust this geometry. We rely on the fact that space separates things. It isolates the burning violence of a star from the fragile, temperate atmosphere of our planet. It keeps the chaotic, colliding debris of the asteroid belt safely distant from our quiet skies. Distance is the great insulator of the universe. It is the physical barrier that gives order to the cosmos, preventing everything from happening all at once in the exact same place. But as we descend past the macroscopic illusion, shrinking our perspective down into the microscopic abyss, we must prepare to abandon this comforting logic. When we approach the absolute limit of physical reality, the Planck scale, the very concept of distance undergoes a catastrophic and terrifying collapse. We are no longer looking at a smooth, continuous rubber sheet. At the bottom of the universe, the unyielding mathematical ruler that we use to measure our lives completely melts away. The void is not a quiet, empty stage. It is a boiling, churning ocean of quantum foam. And in this violent subatomic hurricane, the energy fluctuations are not just happening within space. They are so extreme and so intensely concentrated that they act directly upon the fabric of space itself. Think about what it means for space to boil. In our everyday experience, when water boils, it transitions from a calm, flat liquid into a chaotic, violent frenzy of rising bubbles and rupturing surfaces. The structure of the water is entirely disrupted by the infusion of thermal energy. At the Planck scale, the exact same principle is applied to the geometry of the universe, but the energy is not thermal. It is the raw, untamed, and inescapable uncertainty of the quantum void. The energy spikes are so massive that they physically warp the local architecture of the continuum. The fabric of reality begins to buckle. Microscopic peaks and valleys of geometry rise and fall in a fraction of a microsecond. But the violence does not stop at simple warping. In the classical, macroscopic universe governed by general relativity, the fabric of space can stretch and it can bend, but it is strictly forbidden from tearing. Topology. The fundamental connectedness of the universe must remain perfectly intact. You cannot rip a hole in the continuum. But the quantum world does not respect the clean, geometric rules of the macroscopic cosmos. At the Planck scale, the energy fluctuations become so fiercely violent that the fabric of reality is pushed past its ultimate structural limit. The continuum can no longer handle the stress. The fabric of space actually rips. This is one of the most deeply unsettling concepts in all of theoretical physics. The unbroken stage of the universe physically tears open, exposing a raw, incomprehensible gap in the underlying mathematics of reality. But the universe is fiercely protective of its own existence. The moment the fabric tears, the raw, localized energy of the quantum void forces it to immediately reconnect in new, bizarre, and entirely unpredictable ways. The universe is endlessly, violently sewing itself back together. When the fabric tears and reattaches, it can connect two completely disparate points in space that were previously separated by a vast physical distance. It creates a tunnel. It forms a microscopic wormhole. We usually encounter the concept of a wormhole in the realm of grand science fiction, a massive, glowing portal in the vacuum of space that allows a ship to instantly traverse thousands of light years. But in the deep, boiling reality of the quantum foam, wormholes are not theoretical anomalies. They are the standard, inescapable architecture of the void. They are microscopic bridges ripping open and snapping shut trillions of times a second. Imagine a perfectly flat, two-dimensional sheet of paper representing the fabric of space. If you draw two dots on opposite ends of the paper, they are separated by a clear, measurable distance. But if you crumple that paper into a tight, chaotic ball, the geometric rules completely change. The dot on the far left side of the paper might suddenly be pressed directly against the dot on the far right. The physical distance between them, tracing along the surface of the paper, is still exactly the same. But in the crumpled, chaotic, three-dimensional space they now occupy, they are instantly adjacent. This is what is happening constantly, relentlessly, at the bottom of the universe. The quantum foam is a crumpled, boiling tangle of geometric connections. A microscopic point in space might suddenly tear open and form a wormhole, connecting it instantly to another point a millimeter away, or perhaps a kilometer away, or perhaps on the other side of the observable universe. For a mathematically imperceptible fraction of a microsecond, those two distinct locations in the cosmos share a direct, physical border. They are exactly the same place. And then, just as quickly as the bridge was formed, the energy dissipates, the wormhole violently snaps shut, and the fabric of reality tears and sews itself back into a different, equally chaotic configuration. Because this is happening everywhere, all the time, in every single microscopic cubic millimeter of the vacuum, the entire concept of a straight line is utterly destroyed. You cannot draw a straight line through a boiling ocean of wormholes. If you were somehow small enough to survive at the Planck scale, and you attempted to move forward, the space directly in front of you would constantly tear open and reroute you. A single step forward might instantly teleport you backward, or sideways, or into a completely different region of the continuum. This total breakdown of geometry means that, at the deepest level of reality, direction loses all physical meaning. We navigate our lives using a rigid, mental compass. Up and down are dictated by the comforting pull of the Earth's gravity. Left, right, forward, and backward are dictated by our physical orientation in a smooth, continuous space. But in the quantum foam, There is no smooth grid to orient yourself against. Up and down do not exist. Forward and backward are macroscopic illusions. The void is completely, inherently directionless. It is a shifting, tangled web of temporary bridges and broken paths. Without direction, and without the ability to maintain a straight line, the concept of distance itself simply ceases to exist as a fixed, measurable property. Distance is no longer a solid number. It becomes a chaotic, constantly shifting probability. If you try to measure the exact space between two fundamental particles resting in the vacuum, you cannot get a definitive answer. The space between them is not a static gap. It is boiling. 1 microsecond, the particles are separated by a specific length of warped geometry. The next microsecond, a microscopic wormhole snaps open, and the distance between them instantly drops to 0. A moment later, the wormhole collapses, the fabric tears, and the distance violently expands. The physical separation between any 2 points in the universe is just an average. It is a blurred, probabilistic haze generated by the endless, frantic opening and closing of microscopic wormholes. The distance we experience in our everyday lives, the miles we drive, the oceans we fly across, the vast, freezing light years we measure between the stars, is merely an emergent property. It is a macroscopic illusion created by zooming far enough out that the boiling, chaotic static of the quantum foam blurs together into a smooth, grey average. We are living on top of a shredded, broken reality. The solid, reliable ruler we use to measure the cosmos is fundamentally melting at the microscopic level. To internalize the death of distance is to experience a profound shift in how we perceive our place in the universe. We spend so much of our time looking up at the night sky, feeling the crushing, overwhelming weight of the void. We look at the faint, flickering light of a distant galaxy, and we feel a deep, existential sense of isolation. We feel small because the universe is so impossibly large. We feel trapped on our terrestrial island, separated from the rest of the cosmos by distances so vast that the human mind cannot even begin to properly comprehend them. We build our philosophy and our art around this isolation, exploring the tragedy of separation, the pain of distance, and the terrifying expanse of the empty dark. But the quantum foam reveals that this isolation is a localized biological fiction. It is a trick played on us by our massive scale. If distance is an illusion, if the concept of separation violently breaks down at the fundamental basement of reality, then the universe is not a collection of isolated islands separated by a dead, empty void. It is an intimately, aggressively interconnected tangle. The space between your hand and the screen in front of you is boiling with microscopic wormholes, tearing and reconnecting the fabric of reality trillions of times a second. But so is the space between you and the cold, burning core of a star on the other side of the Milky Way. At the Planck scale, the fabric of the universe is constantly folding in on itself, tying the cosmos into a tight, chaotic knot of absolute proximity. We are not separated from the distant reaches of the universe by a cold, impenetrable barrier of empty space. We are physically, geometrically bound to it. The void is not a wall that divides us. It is a bridge that connects us. The boiling ocean of the quantum foam is the ultimate, unifying foundation of reality. It tells us that the profound separation we feel in the macroscopic world is merely a condition of our biology, not a fundamental truth of the cosmos. Deep down, beneath the flesh, beneath the atoms, and beneath the smooth, deceptive curves of Einstein's spacetime, there is no here and there is no there. There is no far, and there is no near. The architecture of the universe is a singular, writhing, and deeply unified entity. Everything is touching. Everything is connected. The vast, terrifying distances of the cosmos are just a beautiful, continuous illusion, floating quietly on the surface of a boiling, broken, and profoundly intimate reality. There is a singular, invisible force that dictates the entire human experience with absolute, tyrannical authority. It is the ultimate boundary of our reality, an inescapable current that drags us forward from the moment we are born until the moment we die. That force is the arrow of time. We perceive time as a smooth, one-way river flowing relentlessly from the past through the fleeting present and into the unwritten future. It is the fundamental framework upon which we build our sanity. Every memory you hold dear, every regret that keeps you awake at night, and every hope you harbor for tomorrow relies entirely on the absolute certainty that time only moves in one direction. We trust the sequence of events. We rely on the unyielding logic of cause and effect. A glass is knocked off a table, it falls through the air, and then it shatters on the floor. It never shatters before it is pushed, and the broken shards never spontaneously reassemble and leap back up onto the table. The macroscopic universe is strictly ordered by this linear progression. Entropy, the slow and steady decay of the cosmos, provides time with an irreversible direction. The stars burn through their nuclear fuel, biological organisms age and wither, and the universe relentlessly expands, cooling into the dark. Because we are giant, complex biological machines driven by this macroscopic decay, we feel the flow of time deep within our bones. We believe that the ticking of the clock is the fundamental heartbeat of the cosmos, a steady, universal metronome that keeps the chaotic events of reality perfectly synchronized. But to discover the true nature of the universe, we must once again abandon the comforting illusions of the macroscopic world. We must take the fundamental laws that govern our everyday lives and subject them to the terrifying, unforgiving environment of the subatomic abyss. More than a century ago, the rigid concept of a universal clock was permanently dismantled by Albert Einstein. General relativity proved that time is not a separate, independent background feature of the universe. It is not an invisible ticking metronome standing outside of physical reality. Time is intimately, permanently woven together with the three dimensions of space, creating a single, dynamic fabric known as spacetime. This revelation completely destroyed the idea of absolute time. Einstein showed us that time is malleable. It bends and warps under the crushing weight of mass and the fierce presence of energy. If you stand near the event horizon of a supermassive black hole, the apocalyptic gravity warps the fabric of reality so severely that time itself slows to an agonizing crawl relative to the outside universe. Time is a physical dimension, and just like the dimensions of space, it can be distorted, stretched, and violently manipulated. This profound connection between space and time leads us to a deeply unsettling realization. The dimensions of reality are locked together in a shared fate. If space and time are a single, interwoven fabric, they must suffer the extremes of the universe together. When we descend to the absolute basement of physical existence, shrinking our perspective down to the Planck scale, we find a reality that has been shredded by the violent, boiling chaos of the quantum foam. We find an arena where the energy fluctuations of the vacuum are so extreme that the spatial geometry of the universe is constantly tearing open and collapsing, creating a tangled, roaring ocean of microscopic wormholes. If the spatial dimensions of reality are caught in this catastrophic subatomic hurricane, The temporal dimension cannot possibly remain a calm, smooth river. The ticking clock cannot survive the boiling vacuum. At the Planck scale, the very concept of time undergoes a complete structural collapse. To understand how time breaks, we must look at the intense gravitational distortions caused by the quantum foam. In the macroscopic world, it requires the mass of an entire collapsing star to create a gravitational field strong enough to noticeably warp the flow of time. But in the deep, microscopic void, the uncertainty principle demands that wild, massive spikes of pure quantum energy constantly erupt out of nothingness. Because mass and energy are interchangeable, these momentary spikes of extreme energy generate intense, localized gravitational fields. For a fraction of a microsecond, the microscopic environment experiences gravitational forces that rival the crushing heart of a black hole. These violent, chaotic gravity fluctuations grab hold of the temporal dimension and wrench it with unimaginable force. The smooth, forward-flowing river of time is violently disrupted. It accelerates wildly, then slams to a halt, then violently accelerates again. But the distortion goes far beyond a simple change in speed. Because the geometry of space is twisting, tearing, and folding back on itself in the quantum foam, the geometry of time is forced to do exactly the same thing. The local flow of time gets twisted into unrecognizable knots. In theoretical physics, when space-time becomes severely warped, it can create what is known as a closed time-like curve. This is a mathematical path through the fabric of reality that loops back and intersects with its own past. In the macroscopic universe, these loops are generally considered impossible, prevented by the grand, sweeping laws of thermodynamics. But at the Planck scale, the laws of macroscopic thermodynamics simply do not apply. The boiling energy of the vacuum twists the temporal dimension so violently that microscopic loops of time snap open and shut continuously. A fraction of a microsecond folds back on itself, trapping local subatomic events in a chaotic, repeating circle before the loop violently tears apart and reattaches to a different, random timeline. Time loses its direction. It ceases to be an arrow flying forward and becomes a tangled, writhing web of overlapping probabilities. This total collapse of temporal geometry creates a scenario of pure existential horror. It means that at the absolute foundation of reality, there is no smooth sequence of events. The fundamental logic of the universe completely disintegrates. We rely entirely on the absolute law of causality. Cause must always precede effect. The spark must happen before the fire. But in the twisted, boiling knots of the quantum foam, causality is destroyed. Because time is folding back on itself, the sequence of events is completely unmoored. A virtual particle might experience its own annihilation before it experiences its birth. An effect can precede its cause, creating momentary, localized paradoxes that flare up and vanish in the chaotic static of the void. The very words before and after lose all physical meaning. They are rendered completely obsolete. If you could shrink down and survive in the boiling vacuum, you would not be able to construct a narrative of what was happening around you. You could not say that one energy fluctuation caused another, because the temporal relationship between the two events is shifting and breaking trillions of times a second. The timeline is scrambled. The fundamental metronome of the universe is broken. There is no ticking clock at the bottom of reality. There is no rhythm. There is no steady progression of moments falling neatly into the past. Instead, there is only a jittery, unpredictable temporal static. Imagine tuning an old radio dial. When you hit a clear station, you hear the smooth, continuous flow of a song. The notes progress in a logical, linear sequence, creating a melody that moves forward in time. This is how we experience the macroscopic universe. But when you turn the dial into the dead space between stations, the melody vanishes. It is replaced by a harsh, roaring static. That static is not a sequence of notes. It is a chaotic, random blast of all frequencies happening at once, with no structure, no direction, and no meaning. The quantum foam is the ultimate temporal static. The beautiful, continuous melody of time is an illusion generated by our massive scale, while the true, underlying reality of the universe is a deafening hiss of scrambled, disconnected moments. To confront the death of time at the Planck scale is to confront the most profound and terrifying limitation of the human mind. We are conscious beings, and consciousness is entirely dependent on the linear flow of time. You are a biological narrative. Your identity is a continuous story written across the dimension of time, linking the person you were yesterday to the person you are today. You can only think, feel, and perceive because your brain processes information in a strict, sequential order. The firing of your neurons requires a clear before and a clear after to create a coherent thought. But the atoms that make up your brain, the fundamental particles that construct your physical form, are grounded in a reality where that sequence does not exist. The deepest, most fundamental layer of your own body is resting on a timeless, boiling chaos. This forces us to ask a deeply unsettling philosophical question. If time is completely broken at the foundation of reality, why do we experience it so flawlessly up here in the macroscopic world? How does the roaring static of the quantum foam organize itself into the smooth, relentless river that governs our lives? The answer lies in the beautiful, tragic concept of emergence. The linear flow of time is not a fundamental property of the universe. It is a statistical illusion. It is a macroscopic shadow cast by an ocean of underlying chaos. Just as the smooth, continuous flow of a river is actually made of trillions of chaotic, randomly colliding water molecules, the smooth flow of human time is an emergent property created by averaging out the incomprehensible violence of the quantum void. When you take billions of these twisted, broken, and looping microscopic timelines and stack them together, the localized paradoxes cancel each other out. The chaotic static blurs together, and a generalized, forward-moving average begins to emerge, driven by the macroscopic laws of entropy and thermodynamics. We live in the average. We survive in the smoothed-out, thermodynamic blur of the universe. We are completely insulated from the true, terrifying nature of reality by the sheer, overwhelming scale of our own physical bodies. The river of time we are trapped in is a gentle, macroscopic illusion, flowing quietly over a bottomless abyss of scrambled, directionless moments. This realization strips away the absolute authority we grant to the concept of time. We mourn the past, believing it is a physical place that has been permanently closed off to us. We fear the future, believing it is an empty void waiting to consume us. We feel trapped by the relentless ticking of the clock, entirely surrendered to the forward march of entropy. But the quantum foam reveals that this linear prison is a condition of our biology, not an absolute law of the cosmos. At the very deepest level, the universe is not ticking away toward a cold, inevitable end. It is not moving forward at all. It is simply boiling in a state of eternal, directionless turbulence. When you sit in a quiet room and listen to the rhythmic ticking of a clock, or feel the steady, sequential beating of your own heart, realize that you are experiencing a masterpiece of macroscopic filtering. You are hearing the universe smooth out its own fundamental chaos. The order of your life, the clear distinction between your past and your present, and the comforting logic of cause and effect are all delicate, emergent miracles suspended over an abyss of temporal static. We are creatures made of time, fundamentally constructed out of a timeless void. We are localized, biological patterns that have somehow learned to weave the chaotic, looping static of the quantum realm into a beautiful, continuous melody. The sequence of events may be broken at the bottom of the world, but in the fragile, macroscopic layer we inhabit, the narrative survives. We ride the emergent river of time, entirely blind to the boiling ocean beneath us, navigating a universe that is far stranger, far less rigid, and infinitely more chaotic than we could ever intuitively understand. There is a deep and stubborn skepticism woven into the architecture of the human mind. We are, by our very nature, creatures of tangible reality. We demand evidence that we can see, touch, and measure. When theoretical physics begins to speak of a boiling universe, of microscopic wormholes tearing through the fabric of space, and of time twisting itself into unrecognizable knots, it is completely natural to feel a creeping sense of doubt. The mathematics might be elegant, and the equations might balance perfectly on a chalkboard, but mathematics is not reality. It is just a language. To truly accept the terrifying nature of the quantum foam, we cannot rely on abstract theory alone. We demand physical proof. We need to see the ghost in the machine. But how do you prove the existence of something that, by definition, is meant to be completely empty? How do you weigh a void? You cannot simply point a microscope at the boiling vacuum and watch the virtual particles popping in and out of existence. They are far too small, and they annihilate each other with a speed that defies all human measurement. They are trapped behind the veil of the uncertainty principle, living and dying in a fraction of a microsecond. To prove that the empty space around us is actually a roaring, chaotic ocean, we cannot try to catch the particles themselves. Instead, we have to set a trap. We have to design an experiment so exquisitely sensitive that it forces the vacuum to reveal its own hidden strength. We have to force the emptiness to push against the physical world. In the late 1940s, a Dutch physicist named Hendrik Casimir proposed exactly such a trap. It was a thought experiment of profound, almost poetic simplicity, designed to interrogate the absolute silence of the void. Imagine constructing the perfect classical vacuum. We build a heavily shielded, impenetrable chamber. We meticulously pump out every single drifting atom of gas, creating a state of absolute physical emptiness. We plunge the chamber into total darkness, removing every stray photon of light. Finally, we drop the temperature down to the absolute bottom of the thermodynamic scale, removing the frantic, jittering vibration of thermal heat. According to every intuitive law of classical physics, we have now created a realm of perfect, undisturbed peace. The chamber is a dead zone. Now, Casimir proposed placing two small, perfectly flat and completely uncharged metal plates inside this perfect vacuum. We suspend these metal plates facing each other, separated by an incredibly small distance, a gap thousands of times thinner than a single strand of human hair. Under the strict, predictable rules of classical mechanics, absolutely nothing should happen. The plates possess no electrical charge, so they cannot repel or attract one another through electromagnetism. Their physical mass is so incredibly small that their gravitational pull on each other is essentially non-existent. They are suspended in a completely empty, dead void. Therefore, they should simply hang there, frozen in the dark, forever. A passive container cannot exert a force upon the objects within it. But Casimir knew that the vacuum was not a passive container. He knew it was a boiling ocean of quantum foam. And he knew that subatomic particles do not just behave like solid, physical spheres, they also behave like waves. The virtual particles that are constantly, violently tearing themselves out of the dark void and annihilating each other are, simultaneously, waves of fluctuating quantum energy. The empty space inside the chamber is filled with a chaotic storm of these waves, all vibrating at different frequencies and possessing different lengths. Some of the waves are long and slow, while others are incredibly short and frantic. In the vast, open space outside the two metal plates, there are absolutely no restrictions. The quantum foam boils with wild abandon, generating waves of every conceivable size and frequency. But the incredibly narrow, microscopic gap directly between the two metal plates creates a strict physical boundary. Because the plates are placed so intimately close together, they act like a filter for reality itself. A wave can only exist between the plates if its specific length allows it to fit perfectly within that tiny gap. The longer, wider waves of quantum energy simply cannot physically squeeze into the space between the metal. They are mathematically excluded from the gap. This exclusion creates a profound and terrifying imbalance in the very fabric of the universe. Outside the plates, in the open void of the chamber, the quantum foam is generating an infinite spectrum of energetic waves, pushing wildly in all directions. But inside the gap, only a small fraction of those waves are allowed to exist. The boiling chaos is severely restricted. This means that the sheer amount of quantum activity happening on the outside of the plates is vastly greater than the quantum activity happening on the inside. In the physical world, a difference in activity translates directly into a difference in pressure. When the experiment was finally conducted with the extreme precision required by modern technology, the results completely shattered the classical illusion of the void. The two perfectly still, uncharged metal plates did not just sit in the dark, they moved. Without any classical force acting upon them, without any electrical charge, and without any heat or light, the plates were physically, undeniably pushed together. They were crushed by the weight of nothingness. The quantum foam on the outside of the plates, boiling with a full, unrestricted spectrum of virtual particles, exerted a greater physical pressure than the restricted foam on the inside. The vacuum itself reached out and squeezed the metal. This phenomenon, now known as the Casimir effect, is not a theoretical abstraction. It is a measurable physical force. It is the absolute, undeniable proof that the empty space around us is not empty. It is a dense, hyperactive medium, churning with such immense, chaotic energy that it can literally move macroscopic objects in a completely dead environment. We have successfully weighed the void, and we have found that it is incredibly heavy. The ghosts of the vacuum are real, and they have a physical push. But discovering that the vacuum exerts a physical force leads us down an even darker, far more terrifying intellectual path. If the empty space around us is boiling with enough energy to push solid metal, we are forced to ask a deeply unsettling question. Just how much energy is actually hiding in the dark? What is the total sum of the raw power contained within the quantum foam? When theoretical physicists first attempted to calculate this number, applying the strict mathematical laws of quantum field theory to the empty vacuum, they did not just get a large number. They did not get an astronomical number. The mathematics violently broke down and produced an absolute impossibility. When you add up the energy of every single virtual particle across every single possible frequency of vibration, popping in and out of existence in a given volume of space, the equations spiral completely out of control. The math dictates that the energy density of the vacuum is infinite. An infinite energy density implies a complete, catastrophic failure of physics. It would mean that a single microscopic cubic centimeter of empty space contains a limitless, unbounded amount of raw power. Under the rules of general relativity, an infinite concentration of energy would generate an infinite gravitational field, instantly collapsing the entire universe into an infinitely dense singularity. Clearly, we are still here. The universe is not collapsing. The stars are still burning, and the galaxies are still drifting apart. Therefore, the absolute infinity produced by the mathematics must be a flaw in our understanding, a glaring blind spot in our current theories. To resolve this crisis, physicists utilized a complex mathematical process to essentially filter out the impossible extremes, setting an upper limit on the frequencies of the quantum waves. They capped the calculation at the Planck scale, preventing the math from running away into madness. This process successfully eliminated the absolute infinity. But the number that remained, the new, conservative, and mathematically acceptable estimate for the energy hiding within the vacuum, was not a relief. It was a revelation of pure, unadulterated terror. Even with the infinities stripped away, the sheer volume of raw, fluctuating power contained within the quantum foam defies all human comprehension. To grasp the apocalyptic scale of this energy, we must bring the mathematics down into the familiar, macroscopic world. Imagine a standard, everyday object. Picture a simple ceramic coffee cup resting quietly on a table in front of you. Now, imagine that we can construct a perfect, impenetrable seal over the top of the cup, and we use an impossibly advanced machine to extract every single physical thing inside it. We pull out the air, we pull out the drifting dust, we pull out the ambient light and the lingering heat. We reduce the interior of the cup to a state of absolute, perfect vacuum. If you look into that empty cup, your biological senses tell you that it contains absolutely nothing. It is a small, quiet, harmless void. But if we were to take the theoretical calculations of the quantum foam and apply them to the exact physical volume inside that ceramic mug, the reality of the void is exposed as a weapon of planetary destruction. The raw, fluctuating quantum energy boiling inside that single, empty coffee cup is theoretically dense enough and powerful enough to instantly vaporize every single drop of water on Earth. Let the crushing, overwhelming magnitude of that statement settle into your mind. Think of the sprawling, endless expanse of the Pacific Ocean. Think of the crushing, freezing depths of the Mariana Trench, the massive, churning currents of the Atlantic, and the towering, violent storms of the Southern Ocean. Think of every river, every glacier, and every cloud suspended in the atmosphere. The energy required to raise the temperature of that unimaginable volume of water, to boil it all simultaneously and turn the entire surface of the planet into a barren, scorched wasteland of dry salt and steam, is hiding inside the empty space of a single coffee cup. This is the profound, terrifying paradox of the infinite vacuum, the empty space that surrounds us. The silent medium that we move through every single day is not a gentle, passive stage. It is an unfathomable reservoir of raw, apocalyptic power. We navigate our lives feeling incredibly fragile. We protect our bodies from the cold. We fear the violent kinetic energy of a falling rock, and we build massive concrete shelters to hide from the destructive power of a hurricane. We believe that energy is a rare, dangerous commodity that only exists when matter is in motion or when chemical bonds are violently broken. We view the empty air around us as a safe haven, a quiet buffer that protects us from the harsh extremes of the physical world. But the true nature of reality is exactly the inverse. The matter that makes up your body, the solid ground beneath your feet, and the towering architecture of our cities is actually the exception. Matter is a rare, delicate, and incredibly low-energy phenomenon. It is a quiet, frozen state of existence, resting delicately on the surface of a raging, limitless inferno. You are currently immersed in an ocean of energy so intense that it makes the nuclear fusion burning in the core of the sun look like a fading, dying ember. Every time you take a breath, you are pulling a microscopic volume of this boiling void into your lungs. Every time you hold out your hand, you are passing it through a medium so deeply saturated with power that if it were to somehow suddenly stabilize and release its energy into the macroscopic world, the entire solar system would be annihilated in a fraction of a microsecond. The void is quiet only because the energy is perfectly, precariously balanced. The virtual particles are locked in an eternal, localized war of creation and destruction, borrowing power and instantly paying it back, trapping the apocalypse in a microscopic loop. The sheer violence of the quantum foam is contained entirely within the subatomic abyss, allowing the macroscopic world to maintain its fragile, temporary illusion of peace. We are not isolated beings living in a cold, dead universe. We are localized patterns of highly organized matter, walking blindly through an invisible, roaring furnace. The solid reality we trust is just a thin, delicate shell, and the empty space we ignore is the true, terrifying engine of the cosmos. The dark is heavy, the silence is deafening, and the nothingness that holds the universe together is burning with the weight of infinity. We place our faith in the absolute certainty of mathematics. For over a century, human civilization has dedicated its greatest intellectual resources to deciphering the fundamental operating system of the cosmos. Through sheer persistence and staggering genius, we have successfully constructed two monumental, towering pillars of scientific achievement. These two theoretical frameworks represent the absolute pinnacle of human understanding. They are the most rigorously tested, flawlessly accurate descriptions of nature ever conceived by the human mind. The first pillar is Albert Einstein's general relativity. This is the undisputed sovereign of the macroscopic world. It is a deeply elegant, beautifully continuous theory that describes the universe on its grandest, most overwhelming scales. It governs the slow, majestic orbital dance of the planets, the crushing mechanics of collapsing stars, and the sprawling, invisible architecture of galaxies stretching across the deep dark. General relativity relies on the foundational assumption that reality is fundamentally smooth. It treats space-time as a heavy, flexible, and unbroken geometric fabric. It is a universe of deterministic cause and effect, where gravity is simply the natural consequence of massive objects gently bending the continuous canvas of existence. The second pillar is quantum mechanics. This is the absolute ruler of the microscopic abyss. It is the language of atoms, electrons, and the chaotic void. Unlike the smooth, predictable curves of relativity, quantum mechanics describes a reality that is fundamentally jittery, pixelated, and deeply uncertain. It is a world governed entirely by probability, where particles exist as ghostly waves of potential, teleporting through solid barriers and becoming entangled across vast, incomprehensible distances. It is a framework that actively rejects certainty, demanding instead a universe that is restless, discrete, and inherently unpredictable. These two theories are the undisputed triumphs of the modern age. Every single piece of advanced technology we possess, from the satellite navigation systems orbiting the Earth to the microscopic processors sitting inside our computers, relies entirely on their flawless accuracy. But there is a dark, deeply unsettling secret hidden at the very heart of modern science. These two monumental pillars of physics absolutely despise one another. They are built on entirely incompatible assumptions about the fundamental nature of reality. One demands a universe that is a perfectly smooth, continuous sheet, while the other demands a universe that is broken down into jittery, indivisible, and uncertain packets of boiling energy. They cannot both be the absolute truth. For most of the last century, physicists were able to quietly ignore this catastrophic contradiction. We survived by simply keeping the two theories as far apart as possible. We used general relativity to study heavy, massive objects like stars, and we used quantum mechanics to study tiny, microscopic objects like atoms. The universe, in its vastness, rarely forces things to be both incredibly heavy and incredibly small at the exact same time. The realms were separated. The fragile, mathematical peace was carefully maintained. But the universe is not obligated to accommodate our fragmented understanding. The fragile peace we constructed is a macroscopic illusion, an artificial boundary drawn by biological creatures terrified of the dark. And when we finally push our perspective down to the absolute limit of existence, shrinking our awareness down to the Planck scale, the evasion violently comes to an end. The quantum foam is not just a strange, boiling anomaly in the vacuum of space. It is the exact, inescapable battlefield where the two most successful theories in human history are forced into the exact same arena. It is the ultimate cosmic choke point. At the Planck scale, the chaotic fluctuations of the vacuum generate massive, temporary spikes of pure quantum energy. Because energy and mass are two sides of the exact same physical coin, these microscopic spikes generate terrifying, localized gravitational fields. The energy is so fiercely concentrated, and the space it occupies is so infinitesimally small that you can no longer ignore either side of the physical divide. You are dealing with the intense, crushing gravity of the macroscopic world packed into the jittery, unpredictable environment of the microscopic void. To understand what happens in this boiling ocean, theoretical physicists attempt to merge the two theories together. They try to feed the chaotic, probabilistic data of the quantum vacuum into the smooth, elegant equations of general relativity. The result is an absolute mathematical apocalypse. The equations literally self-destruct. When you ask general relativity to describe the geometry of space-time at a scale where energy is wildly and unpredictably fluctuating, the math screams in protest. The smooth, continuous rubber sheet is subjected to the violent, tearing uncertainty of the subatomic abyss. Relativity demands a gentle, sloping curve to represent gravity, but quantum mechanics demands a violent, jagged spike of probability. The mathematics spits out impossible infinities. It produces probabilities greater than 100%, a logical absurdity that breaks the fundamental rules of reason. The formulas collapse into meaningless, screaming static. The concept of gravity shatters the uncertainty principle, and the uncertainty principle rips the continuous fabric of gravity completely apart. This catastrophic collision is why the quantum foam is the single biggest, most terrifying unsolved mystery in all of modern science. It is not just a small gap in our knowledge. It is not a missing variable in a neat equation. It represents a total structural failure in our understanding of the universe. The boiling vacuum at the bottom of reality proves that our two greatest intellectual achievements are fundamentally incomplete. They are both incredibly accurate shadows of a much deeper, much stranger underlying truth that we have not yet been able to comprehend. The quantum foam is the exact threshold where physics, as we know it, violently dies. This realization haunts the quiet halls of theoretical physics. To have the absolute foundation of reality shrouded in mathematical chaos is an existential crisis for the scientific mind. We cannot simply accept that the universe is broken. And so, the brightest minds of our generation are engaged in a desperate, sprawling intellectual war to negotiate a peace treaty between the massive and the microscopic. They are searching for the holy grail of modern science, a unified framework of quantum gravity. The goal is to write a single, elegant theory of everything. They are searching for a master equation that perfectly describes the sweeping, majestic orbit of a galaxy and the violent, terrifying boiling of the quantum foam at the exact same time. In this desperate pursuit, theoretical physicists have proposed radical, reality-bending bridges to unite the two realms. The most famous of these majestic attempts is string theory. String theory attempts to solve the catastrophic infinities of the quantum foam by entirely redefining the fundamental ingredients of the cosmos. In the standard model of physics, we treat subatomic particles like electrons and quarks as zero-dimensional points. They are infinitely small dots of reality. But when you pack fluctuating energy into a single, infinitely dense point and try to calculate its gravity, the mathematics of relativity violently shatters. String theory proposes that these particles are not points at all. If you could zoom in far enough, past the boiling static of the vacuum, you would see that the fundamental building blocks of reality are actually microscopically tiny, one-dimensional loops of vibrating energy. They are strings. Just as the different vibrational frequencies of a cello string produce different musical notes, the different vibrational patterns of these microscopic strings produce all the different particles and forces in the universe. But the true genius of string theory, and the reason it offers a potential lifeline in the quantum foam, is its physical size. Because a string has actual length, it smears out the violent interactions of the void. It prevents energy from ever being infinitely concentrated into a zero-dimensional point. The strings act as a mathematical shock absorber, smoothing over the jagged, tearing edges of the quantum foam just enough to prevent the equations of general relativity from collapsing into infinity. But the universe never yields its secrets without demanding a terrible, dizzying price. For the elegant equations of string theory to work, the mathematics requires the universe to possess 10 or perhaps even 11 dimensions, with the extra, unseen spatial dimensions curled up and hidden away within the microscopic, boiling architecture of the foam itself. While string theory tries to fix the problem by altering the particles that inhabit the universe, a rival framework called loop quantum gravity attempts to fix the stage itself. This theory approaches the horror of the quantum foam from a completely different direction. It asks a profound, deeply unsettling question. What if Einstein's smooth, continuous fabric of spacetime is entirely an illusion? We know that physical matter is not continuous. It is broken down into individual atoms. We know that energy is not continuous. It is broken down into discrete packets called quanta. Why should the dimension of space be any different? Loop quantum gravity suggests that space itself is pixelated. It is quantized. If you zoom down to the absolute basement of reality, space is not a smooth sheet of rubber. It is a sprawling, interwoven mesh of finite, indivisible loops of geometry. These microscopic loops are the fundamental atoms of space. In this framework, the boiling violence of the quantum foam is completely recontextualized. The fabric of reality is not tearing and ripping, because it was never a continuous sheet to begin with. The boiling vacuum is simply the dynamic, shifting, and flickering rearrangement of these geometric pixels. Gravity is just the way these discrete loops interlock and communicate with one another across the dark. Loop quantum gravity attempts to drag general relativity kicking and screaming into the pixelated, discrete world of the microscopic abyss. Both of these theoretical bridges are breathtaking in their mathematical beauty, but they remain fiercely debated and entirely unproven. They are desperate, magnificent attempts by the human mind to cast a light into the darkest, most violent corner of the cosmos. As of right now, the War of the Titans rages on. The ultimate operating system of the universe remains hidden behind an impenetrable, boiling veil of mathematical static. To fully comprehend this conflict is to face the profound, unavoidable vulnerability of the human condition. We build our sprawling, illuminated civilizations, we draft our complex moral philosophies, and we navigate the intricate emotional landscapes of our daily lives, entirely grounded in the belief that the physical world is a settled, reliable matter. We take deep psychological comfort in the solidity of the earth beneath our feet and the silent, predictable reliability of the stars above our heads. But beneath every step you take, beneath the very atoms that comprise the architecture of your own brain, the two absolute rulers of physical reality are locked in a catastrophic, unending war. The smooth, predictable world we inhabit is merely a macroscopic shadow, a quiet, emergent illusion floating on the surface of a deep and violent contradiction. The very foundation of our existence is rooted in a mystery so profound that our greatest, most powerful mathematics physically self-destructs upon contact with it. We are creatures living in the delicate, highly organized ceasefire between the massive and the microscopic. We are suspended over a boiling ocean of reality that we do not yet have the language to describe. But perhaps there is a strange, overwhelming beauty in this fundamental ignorance. The quantum foam reminds us that the universe is not a solved puzzle. It is not a closed book, and it is certainly not a dead, mechanical clockwork. It is a vast, roaring, and untamed frontier. The limits of human knowledge are not a barrier, they are an invitation. The boiling vacuum challenges us to abandon our comforting illusions, to discard our artificial boundaries, and to reach deeper into the dark. We are the universe, attempting to decipher its own violent, chaotic foundation, striving for a brief, beautiful moment of absolute clarity in an ocean of infinite static. We have spent this entire journey descending into the darkest, most violent, and most incomprehensible microscopic abysses of the cosmos. We have watched the familiar laws of physics violently shatter at the Planck scale, and we have stared directly into a boiling, churning ocean of theoretical static where the very concepts of distance and duration completely cease to exist. But we cannot survive in the subatomic dark forever. It is time to pull our perspective back. It is time to ascend from the shredded, chaotic floor of the universe and return to the quiet, familiar shores of the human experience. Take a breath. Look around the room you are sitting in. Look out the window at the sprawling, open sky. Feel the heavy, reassuring, and constant pull of gravity anchoring your physical body to the chair. Listen to the steady, rhythmic ticking of a clock on the wall, or feel the slow, methodical, and sequential pulse of your own beating heart. After immersing our minds in the roaring, unpredictable madness of the quantum foam, the macroscopic world feels like a profound, almost sacred sanctuary. It feels undeniably solid. It feels safe. We experience a universe that appears deeply, inherently committed to order, to logic, and to the reliable, unbroken procession of cause and effect. We build our entire lives, our sprawling global civilizations, and our most intimately held beliefs on this exact illusion of absolute stability. We pour millions of tons of steel and concrete into the earth to build towering skyscrapers, trusting with absolute conviction that the physical ground beneath us is a permanent, unyielding foundation. We chart the sweeping orbits of the planets and the slow, majestic drift of the continents, confident that the geometry of space is a smooth, predictable, and continuous canvas. We measure our days in hours, minutes, and seconds, trusting that the dimension of time is an unbroken river, carrying us safely and relentlessly from the past into the unwritten future. We look up at the vast, empty sky and we see a quiet, passive container holding the stars. We take immense, necessary psychological comfort in the idea that reality, at its absolute core, is a quiet and settled thing. But you now possess a terrifying and beautiful perspective that completely, irrevocably unravels this comforting narrative. You know the dark, violent secret hiding just beneath the fabric of the universe, beneath every single step you take on that solid concrete, beneath every functioning, dividing cell in your fragile biological body, and beneath the quiet, seemingly empty air you are breathing into your lungs right now. Reality is violently churning. The solid ground beneath your feet is not a true foundation. The empty sky above your head is not a passive container. The ticking clock on the wall is not a universal, fundamental metronome. The profound, deeply unsettling truth of modern physics is that absolute order does not exist anywhere in nature. Perfect stability is a mathematical myth. Order and stability are merely macroscopic illusions. They are biological magic tricks, generated entirely by the sheer, overwhelming scale of the physical world and the rigid, necessary limitations of human perception. How is it mathematically possible that a universe built entirely out of a boiling, untamed subatomic hurricane can produce the calm, solid, and reliable reality of a human hand? How does the roaring static of the quantum vacuum assemble itself into a quiet, sunlit room? The answer lies in the staggering, almost incomprehensible power of emergence and the uncompromising law of averages. The macroscopic world we inhabit is the statistical compromise of infinity. Down at the Planck scale, the fabric of space is tearing open and sewing itself back together trillions of times a microsecond. Virtual particles are ripping themselves out of the dark, generating massive, localized spikes of gravitational energy, and instantly annihilating one another in a roaring, blinding static. Microscopic wormholes are twisting the geometry of time into chaotic, unrecognizable knots, completely destroying the sequence of before and after. But there are simply so many of these violent events occurring simultaneously, in such unimaginable, astronomical numbers, that the localized chaos begins to blur. The microscopic paradoxes, the sudden tears in the spatial continuum, the momentary, chaotic reversals of time, they all violently collide, interact, and ultimately cancel each other out. The solid wooden table in front of you is not actually a solid object. It is a sprawling, chaotic, and heavily pixelated probability field of quantum energy. But when you average out the behavior of trillions upon trillions of shifting, uncertain particles, the resulting mathematical shadow looks exactly like a smooth, solid piece of wood. The continuous, forward-flowing river of time that governs the narrative of your life is not a fundamental property of the cosmos. It is the thermodynamic average of an infinite number of broken, disconnected, and directionless moments, smoothed out by the sheer mass of the universe into a gentle, forward-flowing current. We are surviving in the quiet margin of error. The stillness we perceive is just the deafening noise of the universe averaged out to zero. We are completely, mercifully insulated from the true nature of reality by the massive, heavy architecture of our own physical forms. We are simply too large to feel the subatomic earthquake happening constantly beneath our skin, and we are entirely too slow to witness the frantic, boiling genesis of the quantum void. Our biological brains evolved over millions of years to specifically filter out this microscopic static. We were designed to ignore the chaotic foam so that we could hunt, gather, build, and survive in the emergent, macroscopic shadow world. We navigate the heavy, solid simulation because paying attention to the true, boiling foundation of reality offers absolutely no evolutionary advantage. But knowing this, knowing that the smooth, predictable universe is a localized, biological fiction, forces us to completely reevaluate our place within the cosmos. It strips away the deep-seated arrogance of human intuition. We can no longer walk through the world blindly assuming that the physical laws we interact with every day are the ultimate, absolute truths of reality. We are living in a highly rendered, heavily filtered biological interpretation of the universe, generated by the statistical laws of large numbers operating over a bottomless abyss of mathematical static. This realization carries a heavy, almost crushing existential weight. It can evoke a deep sense of vertigo, a sudden feeling of being completely unmoored from the safe, solid ground of human experience. If space can physically tear, if time can tie itself into knots, and if the empty void is burning with the weight of infinite energy, what does that mean for the things we build? What does it mean for the things we love and the legacies we attempt to leave behind? What is the actual value of a human life if the very foundation of our existence is rooted in a meaningless, roaring chaos? When confronted with the sheer violence and the terrifying scale of the quantum foam, it is incredibly easy to feel entirely insignificant. It is easy to conclude that because the universe is fundamentally unstable and chaotic at its core, everything we do in the macroscopic world is just a temporary, fragile arrangement of dust, waiting inevitably to be swallowed back into the boiling sea. But to surrender to that cold nihilism is to entirely miss the staggering, breathtaking beauty of what the universe has actually accomplished. The existence of the quantum foam does not diminish the meaning of the macroscopic world. It infinitely magnifies it. The fact that the universe is built upon a chaotic, violent, and utterly unpredictable foundation makes the emergence of order the greatest, most profound miracle in all of physics. Against all mathematical odds, the boiling, destructive vacuum of space somehow managed to generate a delicate, continuous reality where vast, sprawling galaxies can form in the dark. It generated a reality where massive clouds of hydrogen can collapse and ignite into burning stars, and where heavy, rocky planets can stabilize in the quiet, temperate zones of their solar systems. Out of the tearing, looping madness of the Planck scale, the universe somehow managed to weave a smooth, forward-flowing river of time that allowed for the slow, majestic, and intricate process of biological evolution. And out of that billions of years-long process of evolution, you emerged, a conscious, breathing, and deeply feeling entity, capable of looking back down into the abyss and understanding the bizarre mechanics of your own creation. You are a highly organized, temporary pattern of quantum energy that has somehow learned to walk, to speak, to grieve, and to wonder. You are the terrifying chaos of the void, averaged out into a flawless masterpiece of biological engineering. Every time you forge a connection with another human being, every time you experience the profound, heavy grief of loss, the soaring, electric triumph of discovery, or the quiet, internal peace of a silent morning, you are experiencing the ultimate triumph of order over chaos. You are a living, breathing rebellion against the quantum foam. Your very existence is a testament to the universe's staggering ability to build something incredibly beautiful, continuous, and meaningful on top of a broken, violently chaotic foundation. We do not need the universe to be perfectly solid all the way down to the absolute bottom to find profound meaning in it. The meaning is not hiding in the microscopic foundation. The meaning is in the grand, sweeping architecture we build upon it. The deep love we share, the towering art we create, the complex societies we forge, and the relentless, driving human desire to explore the unknown are all entirely real. They are the emergent jewels of the cosmos. They are rare, precious, and fiercely defended phenomena that only exist because the underlying mathematics of the universe somehow allowed the roaring chaos to quiet down just enough for us to open our eyes and perceive the light. So, the next time you walk outside in the evening and look up at the sprawling expanse of the night sky, do not just see a quiet, empty stage holding the burning stars. Do not just see a passive, silent, and dead vacuum separating our tiny world from the distant, drifting galaxies. Look deeper. Understand that you are staring directly into an invisible, boiling ocean of unimaginable, apocalyptic power. Recognize that the freezing, dark space between you and the moon is a churning, violent frenzy of microscopic creation and destruction, a hidden arena where the familiar, comforting rules of space and time completely stop existing. Let that profound realization fill you not with dread, not with a sense of isolation or insignificance, but with a sudden, overwhelming sense of cosmic awe. You are standing on the surface of an infinite, roaring sea, suspended perfectly in a fragile, beautifully organized, and fleeting moment of cosmic history. Everything you love, everything you have ever fought to build, and every single conscious breath you pull into your lungs is resting delicately, almost impossibly, on the chaotic foundation of reality. We are the improbable, waking dream of a boiling universe, navigating the beautiful, smooth illusion of the macroscopic world, forever tethered to the wild and untamed mysteries of the dark. Good night, and see you in the next video.